Hi, we are students in UiTM Aeropolis. In this video, we would like to talk about titration. Before we start, I will introduce my group members. This group consists of 4 students from RAS 1204H. I am Karina Nabiha binti Mat Jasmani. Next, Nur Alia Arisha binti Muhammad Suhaimi, Nurul Adrina binti Rizwan, and lastly, Raihana binti Ali. Now, let's start with the introduction. Titration is a technique used in chemistry to determine the concentration of a substance in a solution. It involves adding a solution of known concentration, which is the titrant, to a measured volume of a solution with unknown concentration, which is the analyte, until a reaction between the two is complete. This reaction often involves a color change that indicates the endpoint of the titration. Next, we have 3 types of titration, such as blank titration, direct titration, and back titration. Blank titration was defined as titration of a solution that contains all the reagents except the analyte, which is a titration without an analyte being present, only the solvent used in the analyte solution. Next is direct titration. Direct titration, also a simple kind of titration, involves reaction of unknown chemicals with known concentrations of other compounds. It refers to the typical or normal type of titration where the standard reagent, which is titrant, is added to determine the concentration of the analyte until it reaches the endpoint. And lastly, back titration is a titration method where the concentration of an unknown compound is determined by reacting with the known amount of excess reagent. Before doing titration, we need to prepare the material and apparatus. We need to have retort stand, burette clamp, burette, conical flask, pipette, acid, alkaline, and indicator. Next, I'll be explaining about how to do the titration. First, we need to fill up the burette with acid, then use a pipette to add alkaline to a conical flask. Then we need to add indicator to alkaline, about 2 to 3 drops. Then slowly add the acid into alkaline. After that, we have to slow the adding of acid when the solution changes color. Stop adding acid when the permanent color change. We also have to record the titrate. Lastly, repeat the titration for at least 3 times to get an accurate calculation. Next, we need to know how to keep titration apparatus clean. Firstly, rinse the burette with the ionized water. If water beads appear inside the burette, clean it or replace it. Secondly, rinse the burette with the unusual solution. Let it run through the stopcock and out the tip. Thirdly, rinse the pipette with an unknown solution, and last but not least, rinse the conical flask using distilled water.
Next, let's move to theory principles of titration. The basic principle of the titration is a solution is added to sample to be analyzed. The titrant contains a known concentration of a chemical which reacts with the substance to be determined. The titrant is added by means of burette. Here are the key theoretical principles of titration. First, equivalent point. The point of complete reaction between titrant and analyte, typically marked by a sharp change in a measurable property like pH or color. Next, endpoint. The equivalent point is the point where an indicator change color or signal, potentially influenced by factors like indicator error, human error, or impurities. The next one is titration curve. The titration plot shows the pH of a solution against the volume of added titrate, influenced by the titration nature and the strength of the titrant and analyte. Primary standard. These highly pure substances accurately determine solution concentration and are commonly used to prepare non-concentration titrants. Next, types of titration. Titration methods including acid-base, compizometric, redox, and precipitation titrations are based on specific chemical reaction and indicators to determine the endpoint. Calculations. Calculations involve using the volume and concentration of the titrant added to the analyte to determine the concentration of the analyte. This can be done using the stoichiometry of the reaction between the titrant and the analyte. Next, source of error. Titration errors can be caused by inaccurate volume measurements, reagent impurities, incomplete reactions, or errors in identifying the endpoint. Last one, applications. Titration is a crucial method in various fields like pharmaceuticals, environmental analysis, food and beverage, and research laboratories to accurately measure the concentration of substance in solution. The next theory is expected results. Here are a few examples of typical results that might be obtained from different types of titration. First, acid-base titration. The endpoint is acid-base titration involves a sharp change in pH, starting low and gradually increasing until reaching the equivalent point pH around 7 for neutralization. Next, redox titration. The endpoint, a redox titration detects endpoint through color changes or redox potential indicators like iron with potassium permanganate, where total permanganate ion is reduced to colorless manganese ion. The next, compizometric titration. The endpoint is compizometric titration indicates endpoint by forming or disappearing colored complexes like a sharp color change in calcium titration with that acid solution. Next, precipitation titration. The endpoint, precipitation titration detects the endpoint when a precipitate is complete, like when chloride ions react with silver nitrate to form a wet precipitate. The last one, back titration. The endpoint, the expected result is, in back titration, excess titrant react with the analyte and the remaining excess is titrated with a non-concentration solution, determining the original analyte concentration. The last theory is precautions of titration. First, always rinse the burette and take out the bubbles at the nozzle of the burette. Second, always rinse the burette and other flasks with distilled water before using. Third, no tinge of reddish crust should remain at the endpoint. The solution should be clear. The last one is, titration should be performed slowly near at the endpoint for the detection of sharp and correct endpoint. By adhering to these precautions, analysts can ensure the accuracy, safety, and environmental responsibility of titration procedures in the laboratory.
Lastly, the conclusion of the presentation. The proper titration technique ensures precise and accurate concentration measurement. A correct titration technique reduces the risk of handling hazardous chemicals incorrectly, protecting laboratory personnel and preventing potentially dangerous reactions. A correct titration will produce relevant data. Correct titration are vital for scientific research since they serve as the basis for legitimate conclusion and future experimentation. Inaccurate data can lead to incorrect findings, undermining the credibility of research. And lastly, many real-world applications in different facets of daily life.
Promise you now it's my love. You said you want